Hi class, welcome to topic 5 homework number 14. So this will go over number 14 on topic 5 homework. All right, in this homework, we are going to be given various z values or boundaries between two z values, and we're going to be asked to find the area under the curve. Now that table gives us the areas under the curve, but remember that table only gives us the area to the left. So we can't always grab that number on the table and have that be that final answer. We have to manipulate it sometimes. All right, so let's go through some examples. So part A says find the area under the standard normal curve to the right of z equals 1.41. All right, so what's going to happen with this one is when we look up the z value for 1.41, we're going to get the area to the left of it. We need the exact opposite. So to find the opposite, we take 1 minus the area in the table. All right, so let's open our table. And let's find z for 1.41. All right, here is 1.41. So our z value is 0.9207. All right, so this is the value to the left. We need the value to the right. So that's the key here is this word that says right. When it tells you that right instead of left, you want to take 1 minus that number you get from the table. So I'd be taking 1 minus 0.9207. And that will give me 0.0793. So this is the area to the right of 1.41. This is the area to the left. Take 1 minus it, gives you the area to the right. And it said give your answer to 4 decimal places, so then that would be our answer. So 0.0793. All right, so let's look at part B now. So part B says find the area under the standard normal curve between z equals negative 2.09 and z equals 1.56. Okay, so let's go ahead and grab these values from the table, and then we'll talk about how we're going to put them together to find the area we need. So let's go to our table. Let's start with negative 2.09. All right, negative 2.09. So our z value is 0.0183. Sorry, not our z value, our area to the left of negative 2.09 is 0.0183. Now let's find 1.56, and it's right here. So our value is 0.9406. Okay, let's draw out what's happening here. Okay, so for part B, for the z equals negative 2.09, when we looked that value up in the table, it gave us 0.0183. That is to the left. So if we're thinking about our graph, we have negative 2.09 on it. We'd have a vertical line to the left of that. That is what the 0.0183 represents. All right, so then for the z, 1.56. That gave us a value of 0.9406. So then if we had our graph, we would have 1.56. And then remember, zero's in the middle, so 1.56 is on the right side because it's positive. And then we'd be shading to the left of that to represent the 0.9406. So 1.56 to the left of it represents 0.9406. Negative 2.09 to the left of it represents 0.0183. We need to find the area between it. We need to find the area between. So if I'm thinking of my curve, we have 1.56 on the right side, negative 2.09 on the left, and we're trying to figure out the area between. We know the area from 1.56 to the left all the way to the end. We also know the area of negative 2.09 to the left all the way to the end. So what we need to do is we need to take this chunk of negative 2.09 and take it out of this 1.56. All right, let me color code this and see if it helps. Okay, so 1.56 is in blue. So that's this whole area from that one line all the way to the left. Negative 2.09 is red, and it's representing here. So what I need to do is I need to take that red chunk away from the blue chunk, and that will leave me with just the part in the middle. So I need to take out this little red piece from this blue piece, and that will give me just the part in the middle. So what I need to do to find my final answer is to take the area I found for 1.56 and subtract off the area for negative 2.09, because we need to find the area in the middle. So we're going to subtract the two values. So 0.9406 minus 0.0183 gives us 0.9223, and that would be our final answer for part B. All right, there's a couple different ways that this could be phrased, so I'll find a different version and make a separate video for another way you could see part B.